let's welcome the next speaker. I'm extremely happy and excited to welcome Ignacio Chechile. I hope I pronounced his name right. Ignacio has been Chief Technical Officer of ISAI, the famous Finnish company, and he has now moved to another venture, ReOrbit, building modular systems in space. I'm especially excited to talk to Ignacio because his book is right there. He published recently, earlier this year, I think in January 2021, a book called NewSpace Systems Engineering. You will note the S at the end of systems. It's plural. We often see people with titles of system engineering. He spelled it systems. Very interesting. I had a glance at it, and there is a lot to talk about because you could read it with the security angle. So I have many questions for you, Ignacio. Be ready. While you are still settling in, and I'm waiting for the green light of the team here. You talk a lot in the introduction. I think it's very fascinating to also hear about your story, how you got involved into NewSpace, how you thought that there is a need to define a new approach of this NewSpace based on new risk management, and so on and so on. I was absolutely was fascinated by the introduction, and also I have to say the very last chapter, which I strongly recommend. I forgot about the exact title. I'll commit here, but it's about the NewSpace bullshit. Exactly, bullshit as a service. It's great because we at CYSAT are in the startup world. Obviously, you need to sell, you need to present your solution, but beyond that, there is the reality of what is actually being built from the engineering perspective. Let's hear Ignacio about security. Are you with us, Ignacio? Can you hear me?
I think I am. Can you hear me?
Yes, we can.
All right. Can you see me as well? I mean, there is a small problem with my Linux computer. My face cannot be shown at the same time as the slides. Apparently, that feature is not possible. But believe me, you're not missing much.
Yeah, we had a couple of speakers using Linux, which my colleagues said that was a good sign. So we understand it's totally okay if you don't have this virtual PowerPoint as a background thingy that we tried during the event. Please go ahead with your talk, and then we see you after for a couple of questions.
Yeah, all right. Well, thank you very much for the introduction. And yes, Ignacio here. This is the topic that I am presenting today. Cybersecurity challenges is a very long title. Of IP-based space links and COTS-oriented architectures. COTS standing for commercial off the shelf. I kind of hate acronyms, but otherwise the title would have been like even longer. So that's the topic. Maybe a very quick disclaimer before I start is that this is a cybersecurity conference. Now, can I call myself a cybersecurity expert? Probably not. But I can call myself, or at least I can say that I've been involved in the process of developing space systems, let's say NewSpace, the NewSpace way of making space systems from scratch, almost from zero. And I have a pretty decent exposure on some of those early stages where some decisions are taken. And this presentation made me reflect on okay, what was the role of cybersecurity back in those early days? I can quickly answer that the role was non-existent until it grew with time, right? It's not that it never appeared, but in the early stage, not so much. So, I mean, what is it what I do? I mean, I think that Matthew already kind of introduced, but at ReOrbit we design space systems, so that's what we do. We try to explore better ways of making satellites come together and do cool stuff together. So we say that, or we call that kind of teaming up satellites. Basically, I mean, the technologies that we must dominate to achieve this, well, it's autonomy, reconfigurability, and distributed space architectures. That's at the core of what we do. And then connectivity is very much as well, because we want to fly, formations of satellites doing cool stuff. Well, we need to connect them together. So connectivity is very much at the core of it. Hence, security is, right? I mean, if you are communicating or connecting things in orbit, you want to do it in a secure manner. So that's actually what I do, and I'm the CTO in this company. So I am somehow the chief talking officer, as many say, and I try to somehow push for the technological strategy of the company. So NewSpace, yes, I have written a little bit about it, and I can summarize NewSpace in a few ingredients, that I can put here. Thin budgets, tight schedules, quite a lot of corner cutting, and an extensive use of open source. Now, you can already start to see how the combination of all these things can, impact security, because security, when you don't have the money, you don't have the time, you need to cut corners, and you're using a lot of stuff that is from around the place. You can imagine, you can already start to see how the cybersecurity, perspective starts to materialize, that it's very hard to fit it in this blender, let's say. I mean, if we put all these ingredients in a blender, you get sort of a NewSpace thing. But cybersecurity must be an ingredient. Unfortunately, it's not the case, or it's seldom the case, we can say. So maybe a last bit on my background is that I have a fair amount of experience in the classic way of doing space. I've been also working on big satellite, big projects for more like governmental missions. And I can describe the old way, or the classic space way of doing or using space links, which is a very optimal way of using those space links. Every bit means something, and I literally mean it. I mean, it means that one bit in that link means the status of a subsystem, or the status of some fault detection algorithm or something like that. So every bit means something. Then all the packing and unpacking of binary data and turning that into meaningful number, or a light, green or red light that an operator can see, usually happens at the ends of the link, right? Either on board for the software to do something, or on the ground. And there's this very strict, zero overhead policy. I mean, the spectrum back in the day was, well, not very wide. So then, overhead was a bad word. But this started to change because, bandwidth increasing and data rates increasing, the paradigm of every bit means something started to shift a little bit. And there's this Parkinson law that says that, the use of a resource that tends to expand to match the supply of the resource. So the more you have, the more you use, right? And this of anything in life, but in spectrum as well, meaning that it started to show, or started to happen, that the more bandwidth and the higher data rates, well, some overhead start to be okay. And this is when, the sort of newer way of space links kind of, started to appear. And what this means is that connecting to a satellite in NewSpace is already becoming indistinguishable, with connecting to a server over a network. So in some way, which means that operating a satellite is becoming more of a sysadmin task, than anything else. It's like, it's administrating a server on a network. But to unlock the sysadmin concept, you kind of need to heavily rely on IP, and that's basically what we are talking about here. But bringing IP on the table means that, well, in your space link, every bit stops having a specific meaning, because you start to accept overhead, because messages start coming and going without you having a full control, because those are kind of stacks, on board and a stack on the ground, sort of exchanging information without you doing anything. So, and then I mean, ARP messages or TCP IP handshakes, acknowledges, retries, whatever. So when you bring IP on the table, you bring all that overhead as well. And it may sound boring, but we cannot really talk about IP-based space links without taking some scoop on CCSDS, because it's what, in some way, what frames the whole thing. Of course, you can choose your own strange, proprietary protocol, but surely you will end up choosing something that the ground stations also can understand and process and be familiar with. So you most likely will end up going for something like CCSDS. So CCSDS has, a decent description of different layers, and it doesn't really align to the OC layer, or to the OC model, but there is some alignment there. Now, I wanted to bring this image from this document, from this green book, the 130.0 G3 document. That, well, it's very sound, but at the end of the day, I mean, you end up looking at this asterisk in this document, somehow, indicating that, space data link security protocol is optional, right? So, and this is sort of something that really pops up, that security is somehow optional. And let me tell you that in NewSpace, optional means not needed. I mean, at least I'm trying to be a little bit like, I'm exaggerating a little bit, but if something doesn't really show us as a must, well, you push it for some other time, right? And then you focus on, perhaps on your, bigger problems. So that's that. So then the physical layer. So I wanted to bring here also like something that it's like very, very obvious, because we all know that the space links are, of course, exposed, because it's just using the open air. And what that brings is that your space links being exposed to anyone just listening to them. It can happen that your satellite S-band or X-band signal can make it to Twitter, like this example that I'm putting here in the slide. And this is a very little story, that Amazonia 1 is a Brazilian satellite that was launched like a few weeks ago. And there was one guy in Twitter, this guy USA_Satcom, which is it's a great Twitter account that you should follow. He captured the signal from Amazonia, and from the signal he could infer that the satellite was tumbling, because you could see the amplitude of the signal, coming and going, indicating that there was some tumbling. So he posted in Twitter that Amazonia 1 pass on S-band looks to be he was showing the signal, and he said, looks to be tumbling, maybe not so good for X-band. So a very small comment. Well, that small comment made it to the Brazilian media, and this headline here is saying, like, satellite trackers suspect that Amazonia 1 could be out of control. So there was a massive impact on Brazil media, somehow suspecting that the satellite which had been recently launched, could have been out of control, and there was like a massive sort of impact on that. The satellite was not out of control. The satellite was just turning because there was some thermal situation the operators were trying to check. What I wanted to bring with this is that your satellite signal can make it to Twitter. What it's more, your satellite payload can make it to Twitter as well, because these other guys that you should also follow as well, they found a way of decoding X-band data coming from, of course, an encrypted data coming from satellites to the ground, and they made it, to Twitter. And then you can, for example, see this guy who's asking, does anybody know the name of the city? So he's like decoding payload data without even knowing what city it is. And what's more, they are decoding the upper stage S-band video data from SpaceX. So you can see in the Twitter here below that they can decode the actual video link, because the upper stage orbits for takes few orbits and then it's shut down. So probably SpaceX didn't really care to encrypt that, because no big point. So basically, I wanted to wait. I kind of lost the. Here. I wanted to basically kind of prove, or not prove, provide some evidence on the risks on having your physical layer exposed, right? And what does it take to like accomplish well this type of decoding and end up tweeting stuff, it doesn't take much. I mean, with a pretty like small budget, you can put all these things together with some reasonably big dish, and then you end up with some technology. I would say with a few €100, you can build the setup and start tracking satellites. But let's move a little bit from the physical layer and let's go higher up in the layers, and start to talk about the COTS life, the commercial off-the-shelf way of life. Because radio links at the end of the day, they bring bits back and forth, but the protocol rules, they live in the higher layers, of course, in the stacks, and those live inside operating systems, right? I mean, you can have a stack, a TCP IP stack, in a either a real-time operating system or a Linux type of operating system. And NewSpace is, again, talking about generalizing is never good, but there is a tendency of NewSpace using open source TCP IP stacks, like lightweight IP, micro IP, etc. But at the same time, NewSpace is very fond of using, for example, devices without memory protection, ARM Cortex-M or R, these devices are, on the lower end of microcontrollers, and they may, not be like super ready for, protecting processes. So, and on top of that, NewSpace is not very fond of frequent, software patching because it's still seen as risky. So you can imagine the combination, right? It's a bit of a disaster equation where you have an accessible physical layer, you have vulnerabilities, no memory protection, and no patching for vulnerabilities. You kind of know where this is leading, right? I wanted to provide a little bit on substance on, for example, open source TCP IP stacks having vulnerabilities. And luckily, the IoT industry is now pushing a lot of attention into this, because now there's a lot of devices around the place using this stack. So there are like companies around the world, analyzing these stacks. And well, a lot of vulnerabilities have been found, like no surprise there. But the question that I bring here is like, right, I mean, what about space? I mean, how many startups are flying, totally unpatched, IP stacks, full of vulnerabilities? Well, a lot. And I know a story of a small startup, who until very recently used to just telnet their satellites, right, over an encrypted CCSDS link. So it was just, totally, like unencrypted and unauthenticated. So, and on top of that, using, IP stacks who are like very much like outdated in terms of vulnerabilities. So I think that the analogy on satellites and servers that I made in like few slides ago can also, or we can also like stop it for a moment and think that it could be a little bit misleading, right? I mean, unlike servers, IP-based space systems, well, they have the wires open, so that's a big one. But space needs to deal with a very broad spectrum of threats, right? I mean, one threat is a very low sophistication, for example, denial of service, that someone could just jam your space link and then you're out of the game. You cannot talk to your satellite, right? That's why I say that if someone is really determined, a NewSpace constellation can be silenced, with a just couple of, €100 budget, just jamming your satellite every time you're passing, because the information about you passing is like very much like public, right? So that's perhaps, I didn't want to be misleading with the analogy on the servers, even though the concept of operations of satellites in NewSpace is turning into something very similar to a server over a network. That analogy needs to be treated with care, because operating a satellite is not the same as a server. And at the same time, when you break a satellite and the satellite somehow you screw up the firmware and it's just inaccessible anymore, well then your mission is out. Whereas a server, well, you can somehow work around if you can physically access it. So let's be careful with the analogy. I wanted to be sort of illustrative with with the concept of operations moving a little bit away from the point-to-point, historical approach of, connecting to satellites to something more like higher level of abstraction. So some thoughts that I wanted to entertain here is that cybersecurity has to be perceived as a must during the life cycle of the space system development, from the beginning to the end. And that will require some bit of a cultural shift, because many new space companies are like, they have too little money, they have too little time, they don't put it as part of their critical path, and sometimes it's too late. If you add a coding at the end of cybersecurity, it's perhaps not going to be enough, or it could be like too costly to do. And then when we talk about cybersecurity, we sometimes use this term a little bit like lightly, but I mean, a true approach is it has to be a holistic one in a way that we treat all the different flavors of cybersecurity: confidentiality, authentication, data integrity, availability. Partial approaches could be okay, but perhaps not great. So maybe a holistic approach is better. But then the software, when people are developing software, and I am a bit of a software person, so I'm a bit of a, this impacts me as well, that the software has to be designed for space, that it has to be patch friendly. I mean, if patching is risky, but then it invalidates the whole concept, because you need to be comfortable patching your software for vulnerabilities. Otherwise, you will leave like a lot of holes open. Emergency commanding. I mean, I think in the previous presentation, someone said, or at some point someone said that, what about the emergency commanding? Sure. I mean, when you add a lot of layers of cybersecurity and security and whatnot, but then your satellite is having, issues because space is hard, how to get there? I mean, at some point, cybersecurity could, turn around and prevent you from accessing your resources. So this has to be done, properly. Well, this is a bit of obvious bullet, right? I mean, gaining root access to a satellite with propulsion in a very crowded LEO orbit can lead to very nasty consequences. What is more, if someone gains root access to a satellite, in NewSpace, many satellites are commanded with human-readable scripts, meaning that someone could somehow, by just browsing the file system, understand how to command things, because things are, if you have a file system there and you have, a script, in TCL or something like that, you read the instructions, right? So there's not a lot of protection there. And then I put here also like encryption key management, like NewSpace needs to think about that, because many companies are just going, to launch campaigns in wherever place and bringing their, encryption keys with them. And well, organizing those, can be in some laptop here or in some USB key over there. And then those are encryption keys to, to actual space assets. So that's something that, NewSpace needs to really kind of step up the game. And then a question, the boring question a little bit, for this forum is like, how can regulators do something? And I got to know that, well, Germany is leading a little bit on this, and there are like some, security acts, for satellite data security. And I wonder, what can be done, from a regulator perspective, that satellites are only being put in orbit if they somehow fulfill some, cybersecurity measures. Thank you. I have one question to open up maybe for the debate, or the debate that will come afterwards. I have a question that I would like to throw. Is like, what is more secure? What is a more secure way of operating a satellite? Doing telnet on an encrypted CCSDS, layer 2, or SSHing the satellite over an unencrypted, space data link? That is a question that I have. And then the sub question is like how, CCSDS is, because I showed this slide that CCSDS puts security as optional, but that's not entirely true. CCSDS has a, a security assessment of the whole thing. And maybe the question or the discussion that I want to bring is like how, to make CCSDS part of the whole, security architecture, but from every single layer in the stack. No, thank you very much.
Thank you so much, Ignacio. You are definitely a great chief talking officer.
Yes, I went too far maybe over the line with the but it's on time, isn't it? No.
Yeah, we are on time. Yeah. Let's take a couple of minutes. You also you will be back with us later on after the break and after Federico's talk for the panel discussion, so we can take more time for more questions. Yeah. I didn't know the stories about the Amazonia 1 satellite and how you can make it from satellite to Twitter in a very short period of time. I think that we have a couple of questions. You talked a lot about software, patching, operating systems, and I know that Patrick had a few questions for you. Patrick.
Yeah, the first question is about the operating system. You know that Linux has some maturity right now, and they founded 30 years ago. And what about to use Linux operating system in some satellite?
Yeah, I mean, I didn't mention it like very explicitly, but most of my remarks around this presentation are assuming Linux-based also like operating systems.
Absolutely.
It is very much gaining traction, and there is a lot of adoption of Linux in space, which again comes to the question on patching, because in the way that Linux is done, Linux is not microkernel operating system. It's more like it's a big kernel, right? So basically, if you want to patch some things that are too close to the hardware, well, you end up, touching the kernel modules, and that in space can be a tricky game, right? So that's what I'm saying, that Linux is gaining adoption. Now, I'm not sure if Linux is, or let's say the adopters of Linux need to take into account that they may need to update kernel modules as they fly. And that is not for the faint of heart, let me tell you. But if you have a microkernel, operating system like QNX or something similar, then different story, because every driver, everything is like a process that you can just kill and respawn in some way. I mean, I'm kind of simplifying it, but it's easier. But with Linux comes, with these monolithic kernels, comes some challenges.
Great, thank you. And the second question is about you in your presentation. Do you have some analogy between satellite and server? And what about this project to use the satellite like a data center, to have this connection between satellite and this is a new kind of a data center?
Well, I mean, the technologies, I mean, I think that sooner than later it will happen, that somehow storage will move to orbit. I'm not sure when, hopefully soon, for my own sort of personal, advantage. But it will happen. But for that to happen, definitely the protocol stacks need to really much like step up their game, because if you will start having, for example, routers in orbit, and then you will have satellites acting as data relays and IP routers or firewalls or whatever, I think that technologically is totally possible. Now, how ready we are to bring that networking into orbit? Well, some things need to mature a lot, and inter-satellite communication is perhaps also one that it has to step up a lot, because we are very good at communicating satellites to the ground, but not so good at communicating satellites to each other.
Okay. Yeah,
Great.
this is a very broad topic.
Yeah.
I'll take one question from the chat.
Absolutely.
I think you kind of touched that topic, but let's hear you again on that. Ignacio, if you needed to hack a NewSpace constellation, what would be the easiest threat vector, the first one you would attempt?
Sorry, I kind of lost the audio in the middle. If I would have to hack a constellation, what was next?
What would be your threat vector that you would choose to hack that constellation?
No, well, that's a good question. I mean, I guess that I would try to. I mean, I would try to. I mean, I know that there are constellations that are hackable with the least effort possible. Meaning that if you have the basic setup and then you kind of get yourself in the middle, things are unencrypted and very much open. I would go for those first. I mean, without really knowing any particular name, I could already suspect a few. So basically, my vector would be not disrupting things, just to make the whole link crash, but more like try to get myself into the satellite, and then maybe eavesdropping, like with my own setup type of a thing. That would be I wouldn't go for something like social engineering type of a thing, right? That's too boring for me. You need to talk to people, right? I would go for like getting myself into the space link channel, and then just try to find my way in.
Yeah, we talked a lot about key management, and you mentioned it also in one of your bullet points.
Yeah.
Do you think, like we talked about HSMs in the backend, secure elements on board, key management is a big thing, root of trust on board the spacecraft. Do you think this is an overkill for NewSpace? Is it too much? Is it optional and not needed? What is your opinion on that?
Without really knowing a lot about the topic of key management, I think that anything that is better than having keys on USB fobs is better. So I would say maybe stay away from overkills, at least in your early stages, because you are perhaps a startup and you don't have a lot of resources to go big. But don't have your keys around. And I know that sounds silly and stupid, but it happens. So in that sense, I would say start small and increment your key management capabilities as you grow. So let's say attach it to your growth plan, I would say.
Yeah, there are also some very good comments in that book on the design approach for NewSpace startups. I strongly recommend the NewSpace systems engineering book by Ignacio.
Thanks.
Can you show us maybe, I don't know if that's possible, one more time the questions that you wrote at the end so people can see them, and we can maybe talk again about these in the panel discussions. If the panelists are not there, I'll make sure they read it. What is more secure way of operating a spacecraft? Telnet and encrypted SDSS? Or is it, okay.
Yeah. So I have to say I don't have the answer, by the way. I want the answer, so that's why I'm asking it, because I want to know the answer.
I'm turning my head towards another Ignacio from ESA that is attending the event. Maybe Ignacio, if you have a clue, if you have an answer to that, we would love to hear about it, and also other participants. Well, 7 minutes past 11. I think it's time to go for the break. You will be back, Ignacio, so if you have questions in the chat, please send them, and we'll use that in the panel discussion. I'm really excited about that panel. We'll have Federico Belloni that you know. Do you know Federico, Ignacio from Astrocast?
Yes, I think it rings a bell.
He will be with us. Also, Daniel Martin from Cleo Space. Luc Piguet from ClearSpace, and Cesar Cerrudo, CTO of IOActive Security Company.
Oh, cool.
Sounds good. Thanks a lot, Ignacio, again for the great presentation. Super happy that you were able to join us this morning. Let's go on for a break, and we resume at 11:30 sharp with Federico Belloni from Astrocast. Thank you.
Bye. Thank you.